Hi, dear children. So, welcome back to Physics by Imagination. Dear students, in the previous class we had discussed about electromagnetic induction part 1. So, there we discussed that what is electromagnetic induction? That is the process of producing EMF by changing the magnetic field. Again, Michael Faraday's experiment and laws of electromagnetic induction, Lenz's law we had discussed in the previous class. So, in this class, we are going to understand about that is energy consideration, eddy current, inductance, AC generator. So let us understand without wasting time. So dear students, energy consideration. So we had discussed in the previous class motional EMF. So what is motional EMF? When I bring the conductor in the magnetic field, when I change the conductor, if I move it, due to motion of the conductor in the magnetic field, there is a generation of EMF. And we got that EMF is equal to what, children? That is BLV. This is called equation 1. Already we had derived this expression. Now according to Ohm's law, that is what we can tell, V is equal to I into R. Means the current passing through the conductor is directly proportional to voltage. If voltage increases, current will increase. But here I will consider as this is E because this is nothing but electromotive force, which is equivalent to potential difference, amount of work done. So now children, what happens here? Now current is equal to what happens here? E divided by V. Please note down. Now I is equal to what happens? That is E B L V. So I am getting here, this is I into R. This is I into R. Now what happens? E BLV divided by R. This is called equation 2. So this is the expression for current in this conductor. Here as I told you, it is going to convert mechanical into electrical energy. Your charge will be moving. Charge will be moving. So now here, this is the expression for current. Now here we have to show that is mechanical energy of the power is equal to electrical energy of the power. We know that according to law of conservation of energy, energy neither be created nor be destroyed, but we can convert from one form to another form. So now here we got our current. Now we know that according to whenever current carrying conductor kept in the magnetic field experiences a force, that is given by equation F is equal to BIL sin theta. So that is F is equal to BIL sin theta. If theta is equal to 90 degree, it becomes maximum. So it becomes F is equal to B. So I am going to keep this value BL V divided by R. This becomes B into B square LV divided by R. This is called equation 3. So we got this is force on this conductor. Now we want to find power. We know that power is equal to work done by time taken. So work is nothing but product of force and distance. So force and distance, so divided by time. This distance by time taken means what? A displacement by time taken is called velocity. So it becomes F into V. So F into V. So F means this force. V means velocity of this conductor. Velocity of this conductor. Now dear students, if I substitute this, what happens here? B square L V into V divided by R. This is called equation 4. Now what happens here? It becomes B square V square L divided by R. So this is nothing but what, children? That is power in terms of mechanical energy. Power in terms of mechanical energy. Now what is going to happen? I want to find in terms of electrical energy. We know that Joule's law, that is P is equal to I square into R. So this is called equation 3. I am going to write here. So we know that according to electrical power, that is V into I, but Ohm's law, what is there? V is equal to I into R, it becomes PW is equal to I into, that becomes what? IR into I. So it becomes, that is electrical power, it becomes what children? That is I square R. And already I have got the expression that I is equal to BLV divided by R. If I substitute here, what happens here? That is BLV divided by R whole square R. So now A by B whole square, A square by B square. So PW is equal to, that is B square, L square, V square, R square into what happens here? So that is going to become into R. So what things are going to be cancelled? So now here we got that. So PW is equal to B square, L square, V square divided by R. We got this expression. This is called equation 4. Here what is there here? BLV is there. Okay. So already BLV is there here. Again here this is L is there children. So it becomes L is there. Again it becomes L square. Again it becomes L square. A small mistake we did. That is what is children? Here because F is equal to BIL is there now. L is there already. And here L is there. It becomes B square L square V. Okay. Then it becomes B square V square L square. So by using this we can tell that is mechanical energy power is equal to, that is electrical power. So amount of work done nothing but electrical power. So by using this equation we can tell that is energy is conserved, means it has converted, that is mechanical energy of the conductor into electrical energy in the conductor. This is about qualitative consideration of energy consideration. Please note down children. So after understanding this, we'll go for eddy currents. We'll go for eddy currents. Do students, what are eddy currents? So here I am going to keep a magnetic field. Okay, and this magnetic field will be changing. This magnetic field will be changing. Now I am going to keep a conductor. This is a conductor. So I am going to keep a massive conductor. So dear students, in the previous class we understood that the magnet was at rest position, I mean magnetic field, we were moving the conductor. But here, what I am doing here, I am changing the magnetic field and bring the conductor. So I am going to use metal piece. Okay, then what is eddy current means? When we keep a massive conductor between the change in the magnetic field, which generates electromotive force, which generates a current, that is called eddy current. Means the process of producing massive current in the massive conductor when it is kept in the change in the magnetic field are called eddy currents. Uses. Dear students, uses are very important. The first one is induction furnace. That is induction furnace. So induction furnace means what? That is to melt iron metals. We are going to use this principle. Second one is speedometer. So you know that in the vehicles there will be fixed speedometer which finds the speed of the vehicle. And also it is used in dead galvanometer to adjust the damping oscillations. Okay, so that is third one is damping galvanometer. Okay, so next, last but not least, that is in the electrical brakes of the trains. So by using this eddy currents, we can stop the, that is axle wheel of the trains, that is electrical brakes of the trains. So last again, that is we are using in the energy meters to find amount of consumption of power, that is energy meters. So this is all about eddy current. Please note down. After understanding this, let us go for inductance. So what is inductance? The students, you heard about resistance. The opposition to the flow of current is called resistance. Inductance means what? Very easy. This is the symbol for inductor. Okay. So when I pass current, current will flow. Okay. So it is a device which opposes the flow of current, like a resistor, but not resistor. So this is about inductance. So when current flows to inductor, that is called inductance. Okay, this is the symbol. And here, the energy stored, here amount of work done, that is given by directly we can write formula. Let us don't want to do derivation. You should remember that energy stored in this inductor is equal to, that is half into Li square. So this is the L means self-induction. I will discuss. What is self-induction? Our point is to be discussed about what is self-induction. So if I consider a coil, this one, if I pass current here, means self means itself. The process of generation of EMF in the coil and passing of current in the same coil. We are going to produce EMF as well as passing current in the same coil, that is called self-induction. So now here self-induction is given by symbol, that is now magnetic flux is changing and current is inducing. So we can write that is pi is equal to L into I. So we know that according to Faraday's law, what is pi? That is induced EMF is equal to, that is minus dou pi by B dou T. So numerically we can written as, that is minus dou pi B divided by dou T. Okay. So similarly, what we can write, pi is equal to, it becomes dou pi by, so I am going to write as pi is equal to L into I. So that is dt. So it becomes L into I. So now what happens here, this pi value I should substitute. Now if I substitute means pi, what is it? D by dt. Pi means L into I. So pi is equal to, that is, what happens here? This is electromotive force. This is electromotive force, induced EMF. So it becomes what, children? So minus, I am going to take constant outside L, that is di divided by dt. So this is the formula for self-induction. So very important, students, in CET 100% you can expect the question, that is EMF is equal to self-induction di by dt, and this is called 1 Henry. So when do we call 1 Henry? When volt is 1 volt, that is EMF is 1 volt, then 1 ampere of current has flown for 1 second, that is called 1 Henry. Now here, this self-induction we are going to applicable for this number of turns. So now this is called solenoid. It is insulated, means we are going to coat it by large number of copper turns. Then we know that is magnetic field in the solenoid. That is, I am going to erase these expressions. So we know that, and before that just remember mutual induction. The process of generation of EMF in the another coil, change of current in one coil. Means in primary coil if I change current, in the secondary coil is going to produce what, children? That is EMF, that is mutual induction. So similarly we can write that is E is equal to minus L into di by dt. So directly we can write mutual induction is equal to minus M into di by dt. And here L is called coefficient of self-induction, M is called coefficient of mutual induction. Coefficient of mutual induction. Now this solenoid is given by number of turns are there, mu naught Ni. Now N is nothing but number of turns per unit length. it becomes, that is mu naught n divided by L. This is called equation 1. We know that is the magnetic flux which is changing, the product of magnetic field and vector, that is area of vector. So it becomes, that is pi is equal to B into A. So dear students, what is this? This is nothing but what? Change in magnetic flux linked with the coil. Okay, we are going to push the magnet, or we are going to change the conductor motion. Then now if I substitute this, it becomes, so B A is there, it becomes mu naught N IA divided by L. Please note down, very simple. I substituted B value, this one, mu naught N IA divided by L. Now if n number of turns are there, so it becomes n into n, it becomes what, children? Mu naught n square, okay, I A divided by L. So this is called equation 2, means the change of magnetic flux linked with the conductor. So now here we know that pi is equal to, so that is what? Flux is equal to L into I. So then what happens, children? If we substitute L into I, so that is going to change as, so L into I is equal to mu naught times of n square I A divided by L. Okay, mu naught n square I A divided by L. Now I want to find self-induction in the solenoid. So this I cancelled. Okay, so what we can tell, that it is going to become L is equal to mu naught n square A divided by L. This is the expression for self-induction of the solenoid. Okay. Now after understanding this, let us go for next concept. So that is AC generator. AC generator. So you know that what is AC generator? So the children, generator means the device which converts, that is mechanical energy into electrical energy. Mechanical energy into, that is electrical energy. So let us consider a magnet. Imagine this is curve shaped magnet and we have kept a conductor. So now here this conductor is coated by large number of copper turns. So you know that the special property of the magnet, so outside they move from always north to south direction. Now I have considered a small theta, that is called angular displacement. So now we know that from first PUC concept, angular velocity is equal to theta by t, theta is equal to omega into t. This is called equation 1. Remember this. Now what is my point here? Let us consider a conductor PQRS kept between the curved shaped magnets. Then when there is the interaction between the magnetic field and the conductor, it is going to generate EMF. So then it is going to experience a mechanical force. Now change in magnetic flux is given by, in this generator, that is pi is equal to B into A into cos theta. This is, we have taken a resolution of horizontal component. So if theta is equal to, if theta is equal to 0 means it becomes 1, pi is equal to BA. If number of turns means that is NBA. Okay, we can modify, that is ban. Okay, this is called equation 1. We got, that is pi is equal to ban. Now what is my point here? Cos theta is there. If I consider cos theta, you know theta is equal to what is there here? Omega into t, that is pi is equal to BAN cos omega t. This is called equation 2. This is 1, this is 2. Now I want to find the induced EMF in this generator. We know that E is equal to minus dou pi by dou t according to Faraday's laws of electromagnetic induction. So it becomes minus d by dt of ban cos omega t. So this BAN is constant, BA n d by dt of cos omega t. We know that differentiation of cos x means that is minus sin x, but here omega is constant, it becomes omega into sin omega t. So this becomes that is plus ban, that is omega cos, that is cos changes to sin omega t. The students, this is expression for induced EMF, and this is omega band is called E naught, so it becomes E naught sin omega t. So this is nothing but expression for induced EMF in the generator. Suppose they asked to find current in the numericals. So I is equal to, that is we know that V is equal to I into R, I is equal to V divided by R, V nothing but E becomes E naught sin omega t divided by R. This is for current. Now it is going to generate AC current, means the current which changes direction in both positive and negative direction. So this is all about today understood energy consideration, eddy current, inductance, AC generator. Okay, so I hope you understood, children. Please, if you are watching first time, please like it, share and subscribe who are preparing for CET exam. Thank you.